Hi, I'm Alan Michael, and I'm from Delaware Group, and we're running late, so that means Lance is literally somewhere with a cane. Oh, sorry. So while we're doing a laptop microphone swap here, I just wanted to go ahead and introduce our next speaker himself. Jean was very nice in sending me her bio, and she must have understood that we'd be running late. So simply put, she looks after Intel's business into the world of cloud providers. That includes everything Intel does, from servers, storage, network, and compute. So with that, let's do a nice quick round of applause while we get the laptop hooked up, and then we can get going. So thank you.
You guys don't usually get to see all this. This is what happens. Things don't work at first. Wait, come on. Thank you for the introduction. So yes, I've been with Intel 20 years. The last 7, I've been focused on cloud computing. The responsibilities really started about back in the 2007 or 8. We really didn't have a strong position as a company, Intel in the cloud. Actually, our market segment share was below 30%, and on it, we couldn't give away our CPUs. We really had a hard time understanding this segment as a company. So what I'm going to talk about is what has transpired over the last 7, 8 years, and what are we doing going forward? Because what we've done is we've completely turned upside down the way we develop products for this segment, the way we engage with these customers, and the way we embrace trends that come into the market via the cloud infrastructure. And I want to share with you a lot of that learning and optimization, and now what I'll say is customization that we're doing to help enable cloud computing globally, whether it's a cloud service provider building out an infrastructure or if it's private cloud building out an infrastructure. So first, it starts by the demand of data and data generation. More people in the world connecting to the internet with more devices, different kinds of devices, richer media, more complex data is all driving the spiral that's creating data center demand. I don't know if you know this, but for every 400 smartphones that go out into the market, it's estimated that that creates the demand in a data center for one new server. So about this room of people, we could say we're probably running on we created one new server when we powered on our smartphones. It transcends beyond our devices though. If you take medical wearables, which is, the wearables is really hot, for every 100 medical wearables, it takes another server in the data center. For example, we've been partnering with the Michael J. Fox Foundation, and we are working with them on a Parkinson's wearable device that tracks the gait and progression of Parkinson's disease on patients. We funnel all that data through our analytics engine, and we're helping to use that data to find a better cure and treatment for Parkinson's. Once again, it's putting a demand and a strain on the data center. And you can also just look at things like smart signs. For every smart sign, which we now see them everywhere, and they're becoming more in retail, in multiple industries. Once again, 20 smart signs creates the need for a data center server. So all this is fueling growth, and it's fueling a tremendous amount of need and capacity, the need for capacity in the data center. And at the heart of it, how we build out this infrastructure, if we can build it out efficiently, scalably, capably, with security and easier management, we can do a much better job of unleashing the economics of the data center industry and drive new uses, new use cases, and extend computing to more people on the planet. So just looking at a couple examples, everybody in this room should be following everybody in this room should be following the rise of the digital services economy. A lot of you may work for these companies or you're selling into these companies. And one thing is true across all of them is amazing growth and speed. We've listed just a couple here, but I mean, it's amazing to see the transformation. When you take a company like Netflix, now worth about $20 billion, the growth of online streaming of content and media. Or you take a company like Uber, who has completely revolutionized the way you can get a cab. I mean, for the first time, I can come into the city and not fret that I'm going to be standing on a street corner for an hour waiting for a cab, because I actually have a lot less fear about going to San Francisco now thanks to Uber. So it's revolutionized that industry as well. Another company that's worth about $18 billion. I think a really interesting example in this, in the growth, if you know a company called Alibaba, they're probably the largest cloud service provider in China. On yesterday, 11/11, it's not Veterans Day for them, it's called Singles Day. And consider that akin to our Valentine's Day meets Cyber Monday. And it's basically their largest online shopping day of the year. In one day yesterday, they transacted over $9 billion worth of business on one day via Alibaba and their web infrastructure. Think of them akin to like an Amazon of China. To put that into perspective, last year, between Thanksgiving and Cyber Monday, the US was only 5.7 billion. So in one day, they nearly doubled the amount of online transactions. That is the type of economy, and the customers that I'm selling into, I want to create the right infrastructure and products for them so that they can enable that growth and meet the ever-increasing demands and never be left either with underutilized infrastructure or incapable of bringing out new services as fast as they need to. So it's creating a lot of economic opportunity. There are a number of estimates out there, but I think if you kind of triangulate them, you get to a common number, and that number is just really big. They're saying that by 2017, about $450 billion in new internet services. Now, about 60% of this is consumer driven. So this is all, once again, data center growth into things that are probably pure TAM growth for the industry because of the new usages and new services and new companies coming online. But 40% of it is going into private cloud as well, and helping businesses build out, or businesses moving, enterprises moving into public cloud services. And that amount of movement and investment in services is driving a demand for infrastructure, another economic opportunity for many of us in the room who are going to help these customers build out. About $120 billion, which is a significant increase year over year and a very rapid CAGR of this infrastructure. For our company, Intel, when we have our data center business, the cloud segment is probably the single highest year-over-year revenue growth that we are seeing right now across our entire business. It's one of our fastest and growing technologies, and it's purely because of the spiral of demand. And so much of it is just new cream on the top, because it's all new usages and services, and it's that economic movement that's going to help all of our businesses. But, so there's always a but, there's a problem with today. If we're going to ramp up to that demand and be able to sustain it, we can't use the type of infrastructure that's most commonly deployed in data centers today. There are some fundamental limitations about the way we're building out. Some people are building out, or legacy or other, that are building out. And I'm going to talk about three of them and what I see as kind of opportunity for growth into this infrastructure. So the three things are: one, general performance has always been good, general purpose performance has been good, but going forward, it's not good enough. And I'll explain a little bit more what we mean. This isn't a one-size-fits-all, here's my race car and let's put it in every single track. This is, we need to optimize by workload. We also have a fundamental problem today that resources are still very, very siloed. We still have a very static environment. We still manage our compute, our network and storage often individually, and we're not maximizing across the spectrum. And the last one is we're limiting our resiliency and our speed and flexibility and agility in how we deliver these services. how fast we can deliver these services both to our internal customers and to our external customers in the market can actually in many cases make or break a company in terms of their competitiveness in the market. And today we have some big roadblocks that are holding these customers back. So when we look at the data center, we say, you know what? We've got to stop. We have to stop this slow evolutionary approach, and we need to have a revolutionary way of building out data center infrastructure going forward, because this growth rate we're seeing isn't going to slow down, and we just can't afford both the cost or underutilization or the overspend in power. All of those things are going to limit us back from full competitiveness in the market. So that's where I want to talk about what I see as the changes. And when I mentioned that in my job, we spent a lot of time repurposing our roadmap and changing the way we engage to better suit the needs of the cloud service provider market, there's kind of three things we've been working on. One is this concept of customization, silicon customization. One size does not fit all, and we need to have this purpose-built, workload-optimized silicon. Now, we can't walk away from the volume economics of general purpose, and we certainly don't want to walk away from the flexibility that general purpose provides, but we need to build on top of that and still enable it to be completely customized for the unique need and purpose of the business. We also want to break the box. We don't believe compute, network, and storage should ever be confined or constrained or limited because of the walls of a server box, or any type of chassis, or even a rack. The most flexible way to manage your resources is to look at them independently and enable them to adapt and respond, and not to be artificially held within a static box or environment. So I'll talk more about that. And this is also very much aligned to what Mr. Lee was talking about with disaggregated resources. So I'll kind of explain what we're doing here too. And optimized service delivery. We want to help companies accelerate the automation, the orchestration, the provisioning of their resources, have more channels and routes to market. And the way we do this is going to both enable more private cloud build out, but also consumption of public cloud services, because as people can more rapidly and easily consume compute, it drives down the cost of compute, which then makes it more available to the market in many different forms, which is good for the market. So let's step one. We're going to talk about the sandbox and silicon customization. So as I mentioned, a few years ago when we couldn't even give our CPUs away, I mean, there was really one company who was like, seriously, I'm not going to take them anymore, it's free. But we changed that, and it started by one. We re-looked at our Xeon roadmap. We have had a history of innovating and integrating. So we have put more things into our processors around enabling to run lower power, but also power management features, built-in security features, graphics capabilities, all these kinds of accelerators that we built in, and that creates the best general purpose silicon on the planet. And that's good for the broad majority of the market, and actually 95% plus of the market right now is running on 2-socket Xeon in this segment, so it's a really, really good product. But to go forward, we wanted to push the edges even further. So we said, okay, look, there are scenes where workloads are demanding things that are slightly different. There are technical computing workloads and life sciences and oil and gas exploration that need massively parallel many little cores. So we added the Xeon 5 processor to our roadmap to address those workloads and complement Xeon. We also know that there's a segment, the microserver segment, that said, hey, look, let's focus on density first. We need good enough performance, low power, and a cheaper price point. And this was actually a big deal for us to take our Atom processor that had been formerly in netbooks, but out in other computing devices too, and actually put it on the server roadmap. Take data center class features, not sacrifice any capability that you would expect from a Xeon feature-wise and capability. You know it's data center proven, and we put the Atom roadmap together. It now comes out in our TikTok fashion. We've also announced the Xeon D product line, which is our complement to Atom that's going to be Xeon class performance in an SoC form factor. So when that product comes to market next year, we feel it's important that whenever people want to design to, socket should not limit how you design. You should be able to get the range of performance in multiple form factors and choose which of these best products are going to fit your need knowing that they have all the software compatibility and all the consistency and reliability of the Intel architecture spanning from Atom to Xeon D to Xeon to Phi. But even that wasn't good enough, and we moved into the era where we're doing customized solutions. We have announced, we've talked about a couple of these publicly, a lot of them we're developing currently, but what we've done is we've taken our silicon product line and we are customizing it for unique workloads and customer usages. So we're working with a number of the top cloud service providers to really tune, and this can be derivative products where we take the knobs we have available, cores, frequencies, thermals, power, reliability. We can take those things and modulate them, or we can actually create custom derivatives where we're taking customer IP and integrating it into the platform. And that's what we mean by customized, this movement away from a standard roadmap to things that uniquely fit into someone's data center environment that's been designed for them and their workload. Because really what the cloud is about, running applications at scale. So how do you first optimize for that application and then run it at scale? And that's what we're doing through customized silicon. We had about, at the end of last year, so not quite a year ago, we were doing about 15 of these. This year, we're now at 35 with our latest generation of CPUs that we announced, the V3, E5, V3 in September. And we continue to increase that. For us, it was really about breaking that perception or industry myth that we were cookie cutter, hey, here's what I want you to buy, not what you need, to saying, hey, look, we want to work with the partners and we want to, all the way down to taking your IP, because your IP combined with our IP can make a really good addition to your data center. And that's the way we've been moving. And you'll hear from Kushagar after me. He runs all of Microsoft's data center infrastructure, and recently, just a couple weeks ago, they talked about using one of our customized Xeons as they move into the Haswell or Xeon E5, V3 generation for their environment, because their data center is unique and they're one of the largest in the world. So to help them optimize around Intel architecture is something that has been really important, and we want to continue to do more of. So I also want to go a little bit deeper into this low-end part of the segment. You know the Atom, and I mentioned we're actually on our second generation Atom that's been shipping for over a year. We have the Xeon D coming out next year. We have over 90 systems in production right now. We've been doing this for a long time. I've been working on microservers since 2009. I think I can have a kind of claim that that's one of the earlier people working on it. We've been watching this segment because we're excited about it, because we want to explore where the market can go in terms of low power density performance. We want to see how applications can scale. We want to see if we can change the economics and density environment of a rack by mixing in different types of processors. And although the market is still kind of nascent and emerging, I mean, it really hasn't. We haven't seen a dramatic uptake of any of these smaller core type products in the receipt-spotted deployments. We're still investing because we think it can, and it's definitely by workload. It goes back to the workload optimization. There's a lot of networking functions, entry networking, cold storage, storage environments that need to access large data sets, but very infrequently. So you don't want to spend a lot of power or energy keeping something going. You want to go, and just when somebody calls it up, you want to go out there and get it and bring it back. We also see in the kind of simple and static web, we see in dedicated hosting these products have taken off because it's a nice differentiating point. And I'm actually going to let one of our customers speak on behalf of what this product has done. And I'm going to share a little video from our friends at Facebook. If it works.
Today, 1.3 billion people use Facebook. Our mission as part of Internet.org is to connect the next 5 billion people. That presents a tremendous amount of infrastructure challenges, and one of those challenges is actually to think about how we're going to scale all of our storage solutions, especially when you think about the fact that we have over 400 billion photos today in aggregate, with over 350 million new photos showing up every day. You can imagine with 400 billion photos that not all of those photos are accessed and viewed every day routinely. There is definitely a pretty dramatic access pattern Why that's interesting is that we can optimize the storage infrastructure in many different dimensions because of this read pattern, this kind of drop off of what happens.
Now, when we look at that, we look at building a system that scales well, that's energy efficient, and that has the compute power required to run our data storage software. One piece of technology emerged that we thought was very interesting, which is the use of a microserver to connect the storage to our network. And really for us, that's where Intel came in, because they were developing a new series of their Atom processor called the C2000. And the C2000 is designed for microserver applications. The Intel Atom technology really, for us, stood out in this case for a couple of key reasons. First and foremost, it maintains the x86 architecture that Facebook is used to deploying in our data center. And then number two, we found that the Intel platform brought really, best of breed energy efficiency. The power draw of the Intel Atom platform was really quite low, and that allowed us to put a microserver into our storage system without creating a really complex cooling challenge. So we partnered up with Intel and jointly developed a microserver that could fit into our storage system to provide us with that sort of new global storage platform that Facebook needs to handle our ever-growing set of storage challenges. By partnering with Facebook, Intel gains access to quite a bit of sort of scale experience and some of the perspective that Facebook brings. And then Facebook gets access to the vast resources of engineering and technologists that Intel brings to the table.
So you can see that our storage needs and our storage architecture is a critical part of the product, and we also have to never relax or never sort of say that we figured this out, because the game is constantly changing and we seem to be growing faster and faster. So if you think about the overall project, it's about 12 to 14 months end to end. So it's incredible to be able to kind of pull that off and pull it all together with the help of folks like Intel and the team at Intel.
I had to wait for the bong. I have to get the bong in. But that's an example where we had a concept for a product. We knew that there was a customer who was very vocal about wanting to go here. We partnered for a number of months, as you had heard, 12 to 14 months. And what it's done is enabled them to build out this photo storage tier, which is obviously a very large, important part of their business, to access all these photos. And do this kind of thing. So, by the way, those storage designs are part of the Open Compute. So if you we're in the Open Compute Summit in Paris, or you're going to the one coming, you can see those designs. And also you're going to hear a lot more about Open Compute, I think, too, from Kushagar, because Microsoft's been very much engaged and a leader in that organization and bringing, kind of driving those concepts to market. I'm going to shift. I just have a few minutes left. I'm going to talk about a couple of things. We've talked about software-defined infrastructure. I probably don't need to explain it, but it goes back to this concept that there is no reason that we should be building static fixed function boxes. We should not be taking one application, assigning it to a server and a set of resources, and having that be manual or inflexible in the movement. We need to enable agility. And by doing that, we have to still take the value of the underlying infrastructure. It's not about extracting the value. It's about saying, hey, look, the application needs to be in charge. The application needs to be able to call upon the compute network and storage resources it needs at any given moment. And it needs to do that intelligently based on the system attributes of the underlying system. So things like the power or the thermals, or the security requirements or compliance requirements, or any of the type of utilization or SLA type policies. Whatever should be really actually governing the application's performance, it needs to reach down into those system attributes. And to deliver that is what we call rack scale architecture. And you heard from Huawei, they talked about being a part of this. This is a vision for us. It's a logical reference architecture. It's not something we don't go out and sell a rack or a pod or a data center. We are working with the industry. We're working via Open Compute. We're working via Scorpio in China, which is a very similar organization. And we're working directly with many specific customers to take this architecture and make it scalable across the industry. And what it does is it basically says, first you need to pool your resources, compute, network, and storage. You need a very consistent method of exposing those attributes upward so that your orchestration layer can then take and choose and reassign based on the specific system attributes. So what we call rock scale architecture is really this fundamental building block or infrastructure block that enables the orchestration systems to come in and utilize the resources most efficiently and specifically for the unique needs of the data center. And we've been working through a number, as we said, we don't sell this, but we work with a number of industry partners. We have to work not only with the hardware vendors to enable these solutions to market next year, but we also have to make sure that all the major orchestration layers, whether it's OpenStack or Microsoft or VMware, that they are able to consistently read those underlying hardware system attributes and use them upward most efficiently. So you'll be hearing a lot more about this next year from us. It's a vision, and I was grateful to Huawei to mention it too. If you have a chance to come to either IDF or some of our other shows, you can actually see these racks of disaggregated resources and how they move. Another really cool thing about them is if you're going to start having let's say, a bank of compute, and a bank of memory, and a bank of storage, copper cabling isn't going to cut it in terms of connecting long distances. And that's where the silicon photonics technology comes in. By enabling this high-speed transport over greater distance and driving down the economics of that through this technology, it's going to enable us to more easily separate and keep the latency and the performance across these resources as we break out of the box and then re-aggregate them into logical pools based on the needs of the application. And last, I wanted to talk about service delivery. It does matter what obviously I believe it does matter what's inside a service, but enabling faster and better service delivery and provisioning through this orchestration and automation enabling, but also through partnering with the cloud services, we want to see the industry have more transparency into their cloud service so that end users and consumers can make better buying choices about what services they're going to consume that they need. And that transparency really does matter. We've done a lot of studies, but we've also seen next to security, the number 1 and 2 roadblocks for businesses moving their data into the cloud, security and transparency. They want to know that they're going to get the same quality and performance and have all the system attributes that they need in their cloud service as they would if they were managing this on site. So transparency has become a really hot topic in the last couple of years. Companies like Amazon have dramatically shifted. They now, for every single instance, they expose the underlying CPU that are associated with that instances because they found that their end users, the savvy ones, were going out and figuring out on their own through pinging servers and checking. But they found that by exposing it, their users could make more educated business decisions. And a lot of companies have followed suit. There's over 45 companies in the Cloud Finders program and are using the Powered by Intel Cloud technology. But really what we're trying to do is promote the concept that what's inside should matter when choosing the cloud service, and transparency begets more informed decisions, and better decisions and more informed decisions begets better ROI on any cloud investment. So with that, I'll wrap up. The last thing is really about tying this all together. Intel stands on the premise of open. We have 4 to 5 decades of enabling open standards, open systems, open hardware, open source software. We are a company committed that by enabling standards and by creating open ecosystems, we can accelerate the adoption of technology for the benefit of the community. So we are still involved in a lot of these things, academic research, tools and creations, working with the different industry orgs I mentioned, as well as significant open source contributions, OpenStack, Linux, and others. So we want to see all of the things that I just talked about, we want to see them come out into an open system for adoption. So thank you for your time. I ask you to consider what we talked about. Let's break outside the traditional data center. Let's help our customers re-architect for the future, and let's help them be more efficient with both